In this tutorial, we'll discuss methods for calculating descriptive statistics, creating histograms and boxplots, assessing normality, and generating confidence intervals for quantitative variables. Once you have a data set open, and in this case I'm using one called world95.save, which is an SPSS sample file. It contains demographic information from a number of different countries. From the data view, which gives the actual data, use the following procedures to find the complete description of a quantitative variable, including the mean, the median, and the standard deviation, the histogram, and the boxplot, as well as assessing the variable's degree of normality and generating confidence intervals for certain statistics. To do this, first go up to Analyze and to Descriptive Statistics, and then to the third option, which is Explore, which brings up this dialog box. From this box, select the variables that you want. I'm going to use just one in this example, but you can do this for more than one at a time. I'm going to look at the average female life expectancy of these countries, and I click on that and put it into the dependent list for dependent variables or outcome variables. I can put more than one in there if I want, but I'll do just that one right now. Next, go to the statistics box, and from there, make sure the descriptives is checked, and that we have a confidence interval for the mean, and the 95% you can change, but that is the most common number. So I just click continue. I can ignore these other ones for now. Then go to plots. This will give me a box plot with the all groups together making just one box plot. If I wanted to break it down by region of the world, I could do that by putting in the factor list region right here in this factor list. But right now, I'll just make it for everybody together. Also, I'm going to get rid of the stem and leaf, but I do want a histogram, like a bell curve, and I want to get what's called a normality plot with test to see how well this fits the normal distribution, which is a common assumption. Click Continue, and then click OK. This is a syntax command which tells me what I've asked SPSS to do. It's a nice way to keep a record. This is the Explore command, and this says the data set that I use. The case processing summary says that it used data from 109 cases that I complete data on this variable. This is the descriptive statistics, the average female life expectancy per country. The average is 70.16. The 95% confidence interval for the mean goes from 68.15 to 72.16. There's a number of other statistics, the 5% trimmed mean, the median, the variance, and so on. Below that is a statistical test for normality. That is, how closely do the data resemble a bell curve, which is a common assumption of statistical tests. I have two different tests here, the Kolmogorov-Smirnov test and the Shapiro-Wilk test. Both of them give a significance of of less than 0.001, which means that the data deviates significantly from a normal distribution, which is pretty clear when you look at the histogram that we have right here. This is a skewed distribution. Most of the scores are happier in the 70s or 80s, but a few go all the way down into the 40s. We also have a few diagnostic plots with something called a normal QQ plot for quantile, which compares how this would look against a normal distribution. If it were a normal distribution, all the dots from our observed distribution would be right here on the line. A detrended plot is an easier way of looking at it because it flattens it out, and this lets us know that we have not as many as we would expect in the low end. We have more than we would expect here, and it dips down again. If we had a perfect bell curve, all of the dots would fall exactly on this line. And then finally, we have a box plot that shows the median score, the top quartile, or the 75th percentile score, the 25th percentile score, so this is the range for the middle 50%. The highest average life expectancy for any country is around 83, and then it marks the outliers down here separately. This is a useful statistic, a useful way of finding out whether our data meet the requirements of many of the statistics that we're going to do. And that's an introduction on getting descriptive information about statistics one at a time.